So in this video, we will be looking at understanding how the quadratics equations work. So in GeoGebra, you can simply say when x will just give y is equal to x. But once you do an x square, you will get the x square curve. Now let's just see what this means, right? So we already know that squares, one square is one, and two square is four, and three. So the square curves build up pretty quickly. Right? So you have four boxes the height of, nine boxes the height of, 16 boxes and so on. So the square curve is much faster than a y is equal to x curve. This we already know. Because they cross over at 1 because 1 square. The value of x and y are the same. So they intersect here and they intersect at 0 because when x is equal to 0, g of x is 0. Also f of x. It's basically these are all y's. You can think of them as y's. They are 0. Okay. And this curve is an even function, which means if I put a negative number, I will get the same value as if I put a positive number. So this curve is symmetric. So the x square curve is symmetric. You don't really need all the points to draw the curves, and this video is basically going to help understand how I can draw a curve quickly and get a sense of what the quadratic curve should look like. Okay. So x square is clear. The function x is clear. What we can see is that they are both going to be the same, 0 and at 1. So what about the curve that says x square plus x? So if I have x square plus x, I would have thought, no, hey, I'm adding something. But it looks like the curve is actually going down. So let's try to understand why that is. We can do it in many ways. See that the curve is negative in this side and this curve was positive, pulling that down. 0 is still a valid solution. When x is equal to 0, x square is 0 and x is 0. So it will definitely go through 0. Earlier it was touching 0, but now it's going through 0 and it's also because y is equal to x has become negative. It has to compensate for that x and it comes back interestingly at negative. So if we can figure this out, then it becomes easy to understand why that is happening. So in any equation, what is important are the zeros of the equation. What are zeros of the equation? It means when will y become equal to. So in this equation, the first part is of course obvious. If you take common x out, then what do I get? X plus 1. Right? So when x is equal to 0, then y will be equal to 0. Y is equal to 0 is its x-axis, it's going to cross here. And interestingly, when will x plus 1 be? Plus 1 will be equal to 0 when x is equal to negative 1. So that's why this point. So now I have both the points, and of course, has to cross this 0 and has to cross that 0. So if I wanted an approximate curve, I'll know at least where it cross, and then I can draw that curve and get a sense that this is what the x square curve will look like. So this is fairly straightforward. Now the question is, what will, does this give us an insight into what will x square plus 2x look like? I had single x. Well, it's showing you what's going to happen. So x square plus 2x is going to have two zeros. Again, this will always have two zeros. It's a quadratic. It can only have two zeros. It can have only one term. Either the term can be this way or the term can be that way. Yes. Okay. And then other than that, it's going to have two zeros, as I said. And here, what are the two zeros? So x square plus 2. So this will give me x into x plus 2. So again, when x is equal to minus 2, you'll have a 0, that's here. And when x is equal to 0, you'll have 0, which is here. So you can just quickly put those 2 points and then draw the curve and say, well, this is what the approximate x, y is equal to x square plus 2x looks like. So now by now we have figured out what will x square plus any of these numbers plus 3x, then I expect by now that I have understood that when I do 3x, it will cross negative 3x. So let's see. Sure enough, it crosses negative 3x. So any of these x squared plus let's say 6x. So I think by now I figured it out, and also I can, so one thing I figured out is this point. Well done. The next thing I've figured out it is that the curve is obviously going to have to go negative. So the question is how negative and how far will it go negative? So these could be two about an answer. Now in general, this will at the derivative and see when the derivative goes to zero, the slope goes to zero. But since we have not done derivatives by the time you are doing this grade, we will take a shortcut because you know that the derivative of x square is going to be 2. So let's forget about that. We basically say that the curve we knew was symmetric, right? The x square curve is symmetric. So that means that when I have it going through 0 and I am going through 6, that means the peak point in the bottom will be at 3. It will be in the middle, half of that. Right? So this is a shortcut that we are using from what we know. And then all I do is I substitute x equal to, this is not the, this is, so basically I say the peak is going to be half of this, half of wherever it is x. So it's 6 by 2, which is, my peak is going to be here. This peak is going to be at 3. I know. So I put x equal to 3 and I get y is equal to 3 times 9. Okay, so negative 3 is going to give me. So that is the x and y value. X value is 3 and y value is negative 9. So this is one point I'll have. This is one point I'll have. It should give you an accurate enough curve. The bottom part, right? You know what is the peak, you know what is this, you know what is this. An approximate curve is good enough. This gives me the first set approximation of curves like this and what I can expect from them. Then I can also put these points and actually make sure that I have not missed these three important points that I expect where the x is, where the y will be 0 and the y will be negative maximum. Right? So at least the shape of the curve is retained. Okay, next. Now let's start adding negatives. Okay, say square. Yeah. And just add a constant. So I'm going to add, I'm going to go back to basically just my x square. Let's remove all these. And I add 1. Now this is fairly, the interesting thing is now there are no zeros, right? Because x square plus 1, at least again the grade that you're working with, well, it has no real uh, zeros. Where is minus 1? So x is equal to plus or minus j, complex number. So which cannot be represented in the real axis. So as far as we are concerned, the curve will not cross the x-axis, and in fact, where it was going to 0, now it will go to 1, which makes perfect sense. Right? Now, what's not very obvious from any value of x, I should have had a gap of 1, right? So you can't really see it. But if I zoom in, for example, if I now look at 1, 1 was 1, 1 has become, so now it has become 5. The curves look like they are getting, when I zoom out, because the gap of 1 doesn't look very large with large number. Right? The gap of 1 is a very large number. Can't really tell, and I can tell it more obviously here. But this curve, in a sense, will never touch the other curve, and so in a sense is parallel, and it always is lifted by 1. So wherever you go, if you really zoom in, yeah, you will be able to see that this 16, right? If this value is 16, x value of 4 is 16, then this one will be 7. It's not that it will be off, that it's holding the x square plus 1. It is going to. So now I think we are sort of convinced that it makes sense, and what we are doing is not completely not correspond to any logic. It is corresponding perfectly to the logic. So I think this is now obvious that when I add a constant, it just lifts the curve up. So if I add x square plus 10, I expect that the curve will be lifted up. Then once the numbers get big, this thing is zooming out. The 10 doesn't look like. Sorry about that. You can see that the curves do have a gap. So this is 4. There is no doubt about that. Okay. So I know what happens when I add a linear term. I know constant term. So is this going to help me predict, right? If I write an equation, x square plus 2x plus 5, what it's going to look like? Yes. So 5. Okay. Is this according to my prediction? So the first thing is x square plus 2x, I already knew what happens to it. So let's just turn. Let's just do x square plus 2x. Now, what would I expect in x square plus 2x? I expected, because x and 2x has 0, x square plus 2x, it will go through 0, it will go through negative 2. Yes, this is the yes, 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 I have expected this. So, not a surprise. And I also know that at x equal to 1 will be my maximum value, and in this case, be x square plus 2x will be 1, and 2 2, so it will be negative 1. So this value is negative 1, negative 1. Okay, done. So now when I add 5 to it, I lift the whole curve up, and from negative 1, 5 up is positive 4. And so the curve will, that 5, it will go here. It was 0 here, that will become 5. It was 0 here, that will become 5, and then so the curve continues. So I think I've been able to predict this point, which is 5, and that point, which is, or that curve, and go whoosh, whoosh, as an approximate curve of what I expect, which is important to know. If I don't know what to expect, then I can get random points, and I'm not going to be able to draw my curve. So x square plus a fixed coefficient x square plus a fixed coefficient x plus a constant, I should be able to predict. So let's think about it. See if you can do x square plus 6x plus something. Let's say 12. So x square, okay, plus 6x. Now I know what that will be like. There will be, it will cross over at 0, it will cross over at negative 6. it will have the peak at the lowest, or the negative most point will be when x is negative 3. I applied it, I already know that it is negative 9. So I expect that. Let me zoom out up to about negative 8, negative 9, and then I say x squared plus 6x. And as expected, that's where it is, right? And then I'm going to add, I said 12. So negative 9 plus 12 be positive 3. So I'm expecting this entire curve will move up to plus 3, which it does, right? So I am able to predict approximately at least three key points, which is 2 points here and 1 point there, what the value of this quadratic curve is going to be like. And after that, of course, a couple of more points and just draws two straight lines. It sort of looks, it's not a straight line, of course, but the numbers are so big, you can't really tell. The curve is never straight. Curve will always keep going upwards because it's a square. Okay, so I'm going to stop this video here, and then negative coefficient, negative numbers.